Using the conversion factor that we got from the slope, we have that there are about 2.6 grams in every 1 milliliter, or I could also write that as 1 milliliter is 2.6 grams. So I am going to use the appropriate conversion factor to solve these problems. So for the first problem, it says using the conversion factor, or it's also called factor label, predict the mass when the volume is 35 milliliters. So I'm going to start with 35 milliliters. And I like to do where I do like a train track, where I draw a line, I kind of draw the track going across it, and I just put a 1 underneath this. That's just my placeholder there. Now I'm multiplying here, and so when I'm multiplying, it's like I'm multiplying by a fraction, so I need milliliters to cancel out. So in this case, I am going to choose this conversion factor because this will put the milliliters on the bottom. So milliliters, I'm going to do milliliter on the bottom and grams on top from that ratio there. And 2.6 goes with grams and 1 goes with milliliter. Now, when I look at this, milliliters on top here cancels with milliliters on the bottom. The unit I'm left with is grams, which is what I'm wanting. And so when I multiply those together, I'm going to get an answer of 2.6. I'm sorry. Give me 1 second. I'm going to get an answer of 91 grams, okay, when I multiply those together and I divide by 1. So that is how I'm going to do these problems. So for the next problem, it says use the conversion factor and predict the mass when the volume is 90 milliliters. So I'm going to take 90 milliliters, and then I do my train track. So I put that, draw my tracks, and then put a 1 under here. Again, it's really just like I'm multiplying by fractions. So now to cancel here with the milliliters on top, I'm going to need to put milliliters on the bottom here. And the opposite one is grams. So that tells me the conversion factor I'm going to use again is this one. And with that one, 2.6 goes with grams, 1 goes with milliliters. Milliliters on top cancels with milliliters on the bottom. The unit I'm left with is grams. 90 times 2.6 gives me 234 grams. Now for the third one here, I am going to start with the information given, which is it says 87 grams. I do my train tracks and I put it over 1. Now I have the unit on top of grams. So to cancel grams on top, I have to put grams on the bottom. So I look at my two conversion factors, and grams on the bottom here is going to be this one I've just circled. So I'm going to put 2.6 grams there. 2.6 still goes with grams, but now it's on the bottom, and 1 milliliter on top. Again, I took that conversion factor and I just put it right down there. Grams on top cancels with grams on the bottom. And now what I'm going to do is I'm going to take, and I'm putting my calculator 87 times 1, and then I'm going to divide by 1, which I don't have to multiply or divide by 1, and divide by 2.6. When I do that, I'm going to get an answer of 33.5 milliliters. So everything on top I multiply by, and I hit divide by everything on the bottom. And again, I get about 33.5 milliliters. So that's how I'm going to solve a problem like that, and how I pick the proper conversion factor. It says using the conversion factor for question 4, predict the volume when the mass is 20 grams. So I'm going to take 20 grams, make my train tracks, and put it over 1. And I have grams on top. So to cancel with grams on top, I know I'm going to need grams on the bottom and milliliters on top. Now I'm going to look and see which conversion factor will help me. The one with grams on the bottom is this one up here. So again, I'm going to use 2.6 grams here, and 1 goes with milliliters. Now I'm going to, grams on top cancels with grams on the bottom. The unit I'm left with is milliliters. I'm going to, in my calculator, 20 times 1, so I don't have to do that, and then I do divide by 2.6. I divide by everything on the bottom, and I get about 7.7 milliliters is my answer. So that's how I solve this using conversion factors. And if I look back at the table, and I want an evidence here, I'm going to find that my 20 grams, so here, that 20 grams, my answer here, 20 grams is between 18.9 grams and 21.6 grams. And so if I look, is 7.7 grams, where does that fall between? And 7.7 milliliters is between, and from looking at the table, is between 7.1 milliliters and 8 milliliters. And that's from the table. So that tells me, yes, the evidence supports that I did this correctly, because it makes sense. It should fall between it on the table. Finally, it says, what do you notice about the units on the top and the bottom of the factor label method? So this is what we kept pointing out all along, is the top unit and the bottom unit have to be the same. So they are the same. That's how they cancel out. Because really, what mathematical operation are we doing then? Essentially, we're multiplying by fractions, multiplied by fraction, which, what is that really? That is division. What we are doing is division. So this is how you solve the problems using the factor label or conversion factor method. I hope this was helpful.